two pieces of equipment. One built in the 80s, one built in the 90s and built for the future. Other than the fact that one looks a little newer, they don't seem much different. But they are very different. The newer one answers an off-road industry demand to give us a piece of iron that does more work in less time. The new equipment does that very well. But to achieve that new level of performance, manufacturers had to rethink the Powershift transmission. They had to increase power densities beyond limits possible using engine oil as a transmission fluid. That meant developing a new kind of fluid more highly efficient at transferring power into work. It also meant re-engineering the Powershift transmission around the capabilities of this new fluid. The result is a new generation of off-road and farm equipment that delivers exceptional productivity, but only when using a dedicated transmission drivetrain oil. In this video, we'll look at the technology of the Powershift transmission, see how it works, and see why today's newer transmissions need a dedicated fluid to work the way they were designed to work. The goal is not to sell fluid, but to prevent field problems that can arise from the use of engine oil in transmissions designed for a dedicated Powershift transmission fluid. The Powershift transmission was designed for productivity. Many off-road applications require considerable gear shifting and changes in speed. Activities such as dozing, ripping, prying out stumps and rocks, side cutting, pulling implements, skidding logs, and finish grading. A Powershift transmission allows rapid and frequent shifting without loss of power. It also reduces operator fatigue. Both these effects increase productivity. But to achieve them, a Powershift transmission must do one thing exceptionally well: allow friction materials to engage instantly and hold without slipping. If it can't do that, all kinds of problems result. Clutch plates in both the transmission and wet brakes wear out prematurely. Pumps wear out prematurely. Shift response is reduced. Brakes slip. Less work is done, and maintenance is increased. Unfortunately, in today's equipment, engine oil is less effective at keeping friction materials from slipping. There's a basic design reason for this. To prevent slippage, a transmission fluid must preserve friction, but an engine oil is engineered to eliminate friction. In the past, this was not a significant problem. Engine oil has a certain holding capacity, just as transmission fluid has excellent lubrication characteristics. But the increased horsepower of today's engines has pushed power densities beyond the holding capacity of engine oil. In short, engine oil in a transmission is operating outside its engineering limit, and slippage is becoming a big problem. Let's take a look at how slippage affects different components of the transmission, wet brakes, and final drive. There are two types of Powershift transmissions: planetary and countershaft. The planetary gear set derived its name from our solar system. Picture our own sun with the planets revolving around it. In a planetary gear set, a sun gear, which is its actual name, engages planetary gears which revolve around it. These gears are held in place by a planet carrier. They in turn engage and move a ring gear. Planetary transmissions include an arrangement of gear sets which are engaged and disengaged by hydraulic clutches in different combinations to deliver a wide variety of speed and torque. In another kind of Powershift transmission, called a countershaft transmission, the hydraulic clutches transfer power by engaging and disengaging a series of counter-rotating shafts. But in both cases, hydraulic clutch operation is basically the same. Pressurized oil pushes a piston against the clutch disc and plate, clamping them together. The discs are splined to the drum, while the plates are splined to the hub. This sends power through the drum and on through the hub to the output. When the oil pressure is released, the piston retracts, the discs and plates separate, and power flow is stopped. Dedicated Powershift transmission fluids are designed to allow clutch plates to engage without slipping, efficiently transfer power, then disengage quickly. The net result is improved shift time. Shorter shifts improve equipment productivity, increase transmission durability, and reduce operator fatigue. Fast shift response between forward and reverse is equally important, since some off-road equipment operates in forward and reverse equal amounts of time. A dedicated fluid's friction properties provide effective shifting in both forward and reverse to improve equipment productivity.